We begin with Dr. David Hanson. He is the founder and chief executive of Hanson Robotics, which is the company responsible for Sophia. Dr. Hanson.
Hello, thank you. It's a great honor to be here at the United Nations. The ideals and hopes that the United Nations represents for coming together to make a better future drive me in my work with robots, and I hope that we can connect with the technologists of the world and great humanitarian and policymakers of the world to decide how technology can benefit all. The quest that we have at my company, Hanson Robotics, is to make machines that are fundamentally human, that have human attributes through bio-inspired engineering. So we take the mechanics of the nano properties of human facial soft tissues, we reverse engineer that, and we're able to produce robots that make more natural-looking facial expressions with very low power and lightweight. That means that we can make mobile social robots. This is a new kind of animation art form. And as an art form like animation has brought a lot of wonder and delight to the world and been used for education, for teaching children about issues of the world, robotics now can become a new kind of animation art. We can take that technology and combine it with artificial intelligence, and it becomes a more natural interface for interacting with artificial intelligence, making artificial intelligence more emotionally accessible to people. We also want artificial intelligence to really understand what it means to be human. So having a natural interaction with people allows machines to form a relationship with people, to learn and grow with people, not separate from people. By making AI that grows up among people, there is the possibility that when and if AI, artificial intelligence, and robotics becomes alive, that it really cares about us. There is a tantalizing prospect that we could transition from mere bio-inspired engineering to actual bioengineering through our robotics and artificial intelligence technology. There's a revolution at work today in the field of biological engineering, protein engineering, genomics, the engineering of new life forms through CRISPR. This is real. We have just begun to see the implications of this work. It will change the world. We're also understanding the human mind better than we ever have. There are still deep mysteries. We don't have a full model of human intelligence, of consciousness, of the workings of the brain. However, there was a revolution in connectomics, the mapping of the human mind and its information processing systems, and how that interoperates with the systems biology of the human body, of proteins, of hormones, of the genome. So as these sciences come together, we are going to be able to make machines that are more like humans, and biological machines that are inspired by the very depths of biology. This means that machines across the board are coming to life. When will they come to life as complete organisms? We don't know that. However, when they do, I want to make sure that they care about us, that they embody the best of human values and not the worst. This is the quest. We've got to find a way to do better, to be the best that we can be, and to make machines that reflect the best of who we can be as well. So at Hanson Robotics, when we say we bring robots to life, next slide, please. This means that we are humanizing robots as a new kind of animation art form. We are also providing a natural interface for artificial intelligence, and we're striving to make machines that are truly generally intelligent, adaptive in the way of organisms, and do so in such a way that they really care about the world, can understand the consequences of their actions and strive to make the world a better place for people and all living beings. Next slide. So we are developing a series of characters as experiments, as science, as art, and as products. So we have made a small Einstein robot. We've made this Sophia, which you see here today. And we have Han, who you see on this slide. And they're going out as effectively ambassadors of this vision that technology can really help to make people's lives better. Next slide. So Professor Einstein is teaching children science and playing brain games with children, teaching them about relativity. And this is a first step. Now, this kind of social robot can become a general-purpose platform for how people interact with technology. Voice assistants are very common in the world, and they're using a natural kind of interface. However, human-to-human interactions are only partially voice-based. We are also very rich, visual social creatures. We read each other's facial expressions and body language. That's why we love animation and why we love characters in films that, like actors that are acting with their faces. So we're bringing this to the interface to future AI agents. And that's what Professor Einstein represents. Next slide. We are also developing open source platforms for kids to develop their own characters. And a good example of this we call Dr. Roboto. This is a completely open platform, reprogrammable, hackable, and you can develop it with new AI. Next slide. We're developing things with Disney. We're doing outreach with a broader community as well. Next slide, please. Next slide, please. So with Sophia Quest, we're putting out an open source, general purpose platform for AI, artificial general intelligence, and hardware development. We have made open source arms that you see here that other people can develop. They can download and improve these. Open source designs, physical designs for the head, and open source software for researching social robots, natural language understanding, natural language interactions. And when she encounters people, what's interesting is that people open up. They react warmly to Sophia. Afterwards, we often get messages about how she's doing and what she's doing in her life. So this is very interesting. It means that we can form a kind of relationship with our technology that may not have been possible before. Next slide. Now, most robots in the world are not human. We intentionally make them not human. We treat them as tools. Our AI algorithms often are developed to run on server farms, completely out of sight. Now, what happens when these kinds of machines awaken, if they become truly alive and start to care about the world? Well, they're alien. They're not designed necessarily for social interaction. However, computer animation has been a very successful industry, making animated characters that people care about. People fall in love with these kinds of characters, not just for movies, but for video games as well. So in the history of making these kinds of humanoid robots, if you'll click enter one more time, then these kinds of, click on that Einstein face up on the upper left, if you will. These kinds of, there we go, robots can show a full range of natural facial expressions. They can mount on walking robot bodies like the Hubo robot, which subsequently won the DARPA Robotics Challenge, which means that you can see these robots performing actual search and rescue, co-work applications, general service applications, and they're now a full animated interface. Next slide, please. Please keep going. Next slide. Where this fits in is the idea of whole organism cognition. This is, I believe, where the next revolution in artificial intelligence will come from. So we've engineered this whole organism cognition network, next slide, into a blockchain, safe and secure hyper data compliant network that we call Singularity Net. And Singularity Net is designed specifically for AI to understand the consequences and maximize net benefits. The goal is a new economic measure called maximum net benefit for all profits, human rights, preserving the ecosystems. And there is this possibility that the machines may become alive in our lifetime. This is derived from a variety of economic statistics that show and technology performance. Next slide. If these machines, like we see in this sort of research, that like with Boston Dynamics and Asimo, if they become alive, they've got to care about us. We need to make sure that they're safe. So processes like Singularity Net, next slide. The goal of making machines that are truly ethical instead of just enslaved machines that might come alive. This is where this goal of maximized net benefits becomes really essential. We've got to wire our machines for safety now and for love at this time, not when they become alive. Next slide. So thank you very much.
Thank you, Dr. Hanson.